welcome to this tutorial about how to do natural language understanding with Fantasia and Azure Language Studio. Azure Language Studio substitutes Microsoft LUIS, so this tutorial substitutes the old one, and what you will see here works with Fantasia 5.2 onwards. So first of all, let's get into Language Studio and let's reconstruct the example that we had in Microsoft LUIS with a few changes made to highlight what's new in Language Studio. So basically we have a list of intents and a non-intent. We have get acted in with a movie entity. We'll talk more about entities in here. Get acted in is the intent concerning getting all the actors that appeared in a certain movie. And actor movies with an actor entity means that we want all the movies in which a certain actor appeared in. Or this new intent, get by prize, is made to select all movies that won certain prizes, awards. So if we get into the specific intents, we can see that we have some examples of get acted in. So who starred in As Good As It Gets, tell me the cast of A Few Good Men, etc. We have the possibility to filter other intents. So for example, we can get other intents here, and we can have get actor movies. Can you tell me which movies did Jack Nicholson star in, which movies did Susan Sarandon appear, etc. And we have labeled these names and titles as entities, actors and movies. If we look at the entities here, we can see that the actor entity has a learned component, which is automatically created when we label utterances, and we have a list component with all the names that are found, for example, in a database with possible synonyms. In Language Studio, entities are treated a little bit differently than they were in LUIS. Now, entities can be defined in terms of composition of sub-entities, and each different type of sub-entity can be made required or not. Required components for these entities mean that an entity will only be returned if Language Studio is able to recognize the specific sub-entities. So, actors and movies can be modeled with simple list keys, because we only want to recognize what we have in the database. We can add learned components to also recognize movies that we do not know in the database, so that we can answer things like, okay, I understood that you're looking for a movie or an actor, but I don't know this specific movie or this specific actor. Let's get deeper into entities, and let's look at the prize entity. So the prize entity has basically three components. We have a quantity number, so a pre-built entity of type number, and a list, two lists actually. We have Academy Awards, plurals, etc., and Golden Bears. In this way, we can have utterances like, okay, tell me a movie that won at least 2 Oscars, so that the entire entity will be recognized as 2 Oscars, 2 Academy Awards, and we will be able to recognize that 2 is a quantity and that the type of prize is normalized onto the key value. So if I say 2 Oscars, then the outcome of Language Studio will be 2 as a quantity and Academy Award, substituting Oscars with Academy Awards for normalization. If we start labeling prizes in utterances, we will also have a learned component that recognizes the context in which this kind of entities appear. So let's take a look at data labeled with, for example, get by price, intents, and here you have recommend a movie that won 2 Oscars and a Berlin Bear. So by labeling 2 Oscars and Berlin Bear as prizes, we are adding a learned component to the prize entity. Once you have your data in here, you can train your model, start a training job, and wait for it to complete. Then you deploy your model, so it can be reached, can be queried outside Language Studio, and we can test what happens in the model. So I already trained and deployed the simple model that I showed you, so let's use it. And let's test this sentence, recommend a movie that won 2 Oscars and 3 Berlin Bears, just to see what happens around the test. So, Language Studio recognized that the intent is get by price with a high confidence. Of course, I think this was also one of the training set examples, so very hard for it to miss it. And it recognized 2 prize entities, 2 Oscars and 3 Berlin Bears. If we look at the structure of this, we can see that we have the full list of possible intents with the different confidence scores. We have the list of entities, and for each entity, we also have its sub-entities. So these 2 Oscars is a prize entity, and the number resolution maps 2 onto the value of 2. And we also have this entity subtype, which represents the 2 quantity number, and we know that we found a component as a list key, so an Academy Award, while 3 Berlin Bears, it has the same structure, but in this case we have 3 as quantity number and a golden bear. So this is what Language Studio does. Of course, you can refer to Microsoft's documentation to get deeper inside Language Studio. But what we need to check now is how we can access this information in Fantasia. So let's switch now to Unreal. In Unreal, we have modified the blueprint, the example blueprint of the old tutorial, so that we can check what happens if we say the exact same sentence that we had in Language Studio, so that we can output how this is interpreted in Unreal. So first of all, we need to configure the new Azure NLU component. This time, we will need to specify separately both the configuration of the ASR and the configuration of the natural language understanding part. You can get your speech key, region, and language by following the tutorial about ASR. These are the same keys. While here, in language key, you need to put the key that you get from Language Studio under Settings, and here, primary key. Back in Unreal, we have the project name and the deployment name. Again, you have this information in Language Studio. The endpoint of your resource can be found in the Azure dashboard. So Language Studio is linked to a language resource. The endpoint that you need to put here is the endpoint that you find in the configuration of the language resource under the Azure dashboard. Once you have configured this component, we can use the usual strategy. So we will use spacebar to start the NLU, and we will write a listening message to have some kind of visual feedback. When Azure responds, we have the transcription here of what I said, and we have 2 lists of entities and intents. So for now, we only want to get the highest intent, the highest confidence intent. So we simply get the first one, we get the intent name, and we print it in blue. Then we move to the list of entities. We cycle over these entities, and we write both the entity that has been recognized with the type that has been recognized. And we will write this in light green. To recognize sub-entities, you can access the children sub-array of each natural language understanding entity and cycle over these. So for each child of this entity, we will write again the entity and its type in red here. So I will use the same sentence I showed you before. So we will have something like recommend a movie that won 2 Oscars and 3 Berlin Bears, with the same deployment. Again, here it is. We should get the same structure into Unreal as we see here in Language Studio. Recommend a movie that won 3 Oscars and 2 Berlin Bears. And here we go. We have the get by prize intent. We have 3 Oscars identified as a prize, with 3 as a number resolution. There is a quantity number entity subtype and the Academy Award as a list key. And the same thing happens with the Berlin Bears. So in this way, we can say something and get the natural language interpretation from the new Language Studio resource in Azure. So again, please remember, this substitutes the old approach with Microsoft LUIS. So natural language understanding in Fantasia is now performed mainly with Microsoft Language Studio, starting from Unreal Engine 5.2. Thank you everyone for listening, and have fun with Fantasia.